isn't on the call, I can go ahead and introduce Leke. He is currently a fifth-year student in the bioinformatics program at UGA, and today he'll be presenting some of his work using phylogenomic epi. And with that, we didn't really discuss who would start. Okay, perfect. Leke, first. Take it away, Leke.
All right, thanks, Udi. All right, let me figure out all the slides and everything. Cool. All right, so hello everyone. It's really excited to give a talking here. I'm from Dr. Ball's lab. I'm currently planned to graduate this year. So the title of my talk today is Phylogeographic Inference of SARS-CoV-2 Delta Wave in Texas, USA, using a novel spatial transmission count statistic. I study genomic epidemiology, so this is a field that utilizes pathogen genomes to study the spread of infectious disease through population. But what does it mean? Imagine we have a complete transmission chain here. RNA viruses like SARS-CoV-2 have high mutation rate and short generation times. That means mutations accumulated in the viral genome during the transmission. Of course, we cannot sample all of them, but even though we sample only a fraction of individuals, we can still construct a phylogeny tree that actually represent the relationship among the sample individuals. Then we can add some extra layer on top of that tree, make inference about timing and directionality. So we can make inference like this. So there's an ongoing outbreak in the community, and it was transmitted to the university around epi week 16. Genomic epidemiology can also help us identify transmission clusters and cover demographic characters contributing to transmission patterns, and also help us evaluate public health policy. So in general, we have this well-developed framework of molecular epi analysis. We have this viral phylogeny, and we can infer a time tree. We can do the trait analysis through a clock model, population dynamic, and trait evolution model. And then we can summarize or translate this information into epidemiological inference. But SARS-CoV-2 is definitely a game changer because a typical data set will easily over like 10,000. So imagine a compact tree with more than 10,000 of tips. How can we translate the time, the location trait into readable epidemiological inference? So in our study, we came up with this new transmission count statistic. Let's take Texas as an example. So Texas-related transmission can classify into importations, local transmission, and exportations. Well, given the phylogeny, the nodes are colored by either non-Texas or Texas. And based on that, we can cover the branch on the tree into importations, which is from non-Texas to Texas, local transmission, which is from Texas to Texas, and exportation, which is from Texas to non-Texas. So in this example tree, you can see in epi week X, there are 6 cases of importations, 9 cases of local transmission, and 3 exportation. So we are guided by this viral phylogeny, we summarize the weekly count of local spread, viral inflow, and outflow, so illustrating the transmission trend over time. This is like translating information on the tree into readable information. we also come up with two quantitatives to compare transmission trends between regions. We want to compare repeat introduction versus continuing local spread. We have this local import score. It's a count of import over the count of import plus count of local transmission. We also have this source sink score to help us identify viral source and viral sinks. So the local import score will range from 0 to 1. The source sink score will range from -1 to 1, a value more close to -1, meaning that's a sink, more close to 1, meaning that's a source. Now we're coming to this case study in Texas. So this is a map of Texas. Counties are colored based on their RUCC code. So RUCC code represents, so this is a classification of metro areas. Texas have 25 metro areas, but of course this metro area don't have, they have different population size. RUCC1 representing the most populous regions like Dallas, Houston, Austin, and San Antonio, and then RUCC2, RUCC3, or any population, housing, and territory exclude from metro area or classified as a rural region. So in this case study, we collect over 10,000 of sequences in which over 5,000 were from Texas and over 6,000 were globally contextual sequences, helping us to know the timing when the introduction happens. So the first question we want to tackle is, what does the epidemic in Texas look like, right? We build this compact phylogeny containing over 10,000 of sequences. So the branches were, sorry, let me go back. So the branches were colored as importations, local transmission, and exportation. And you can see it's very hard to grasp information from it. But our transmission count statistics show the epidemic trend in Texas in a clear and a simple way. We can know the initial introduction in Texas began in late March, which is like 2 weeks ahead of the first medical record. We can also find out like the epidemic peak occurring around July 2021. Let's have a closer look of this trend. So we observe like Texas has actually multiple import and export to the global pandemic. And the epidemic in Texas was primarily driven by local transmission, which is a blue line here. Now let's go to the second question. Where are the source of this viral spread in Texas? So we redo the trait analysis. We summarize the epidemic trends in this subregions, which I mean the metro areas and compare and the compact rural regions, and then we calculate the accumulated the sourcing score. So the result is pretty clear. The box plot showing here the RUCC1 representing the most populated urban centers have the highest sourcing score, meaning they are the major source of Delta pandemic in Texas. In the last part, we'll just have a close comparison between the epidemic in urban centers and rural areas. So we want to see like how exactly quantitatively what's the difference of the epidemic in between these two regions. We pick Houston as an example, and we compare it with rural areas. The compact rural areas takes most area of Texas, but has a population over 3 million. Houston has a population over 7 million. The trends in here is epidemic trends. It's a little messy in here, but don't worry. So first, we find out like Houston has a higher level of viral flow with global contacts. So you can see over 50% importation were actually from non-Texas, which is the global contacts, comparing to rural is only 27%. And there are 19% of exportation is to the global contacts, which is bigger than 12%. In here, we calculated the weekly local importation score. In here, we found out that epidemic in Houston was locally maintained, but the epidemic in rural regions relied on external introduction, because in this rural region they have really high local. This score shows really high. In the last part, we compare another metrics in here is the source sink score in here. It clearly shows like Houston serve as a viral source and the rural area function as a viral sink. Okay, in the summary, in here first we came up with a novel transmission count statistic. So guided by the viral phylogeny, we summarize the weekly count of local spread, viral inflow and outflow, illustrating the transmission trend over time. To quantitatively compare transmission trend between regions, we have these two matrices. For the case study in Texas, we found out highly populated metro area, they are the source. These urban centers well connected the epidemic to the global outbreak. And at last, the epidemic in urban centers were locally maintained, while the epidemic in rural regions relied on introductions. And that is my last slide. Thanks for the help from my lab. Thanks my my tutor, Dr. Ball, and Dr. Spencer Fox of this research. And in here, I think I need to stop sharing.